One of the common ways to use quadratics is to solve problems involving area or perimeter of space. So I'm going to do an example with you here that shows you how you can use a quadratic. The question is that you have 60 meters of fencing to enclose a rectangular space. Find the dimensions that maximize the area. The first thing to think about when you're talking about looking at the question is to really decide what information you've been given. If we're talking about fencing, we're really talking about the perimeter of that rectangular area. So it's important to know that perimeter is 2 lengths plus 2 widths, and we want to maximize the area, and area of a rectangle is length times width. So let's start with the information that we've been given and see if we can come up with a quadratic that only has one variable, because we don't want length and width in our quadratic. We want either length or width in the quadratic. If we take our perimeter formula, we know that the total perimeter that we have is the 60 meters of fencing. So 60 equals 2 lengths plus 2 widths. So that means we could solve for the length and get it by itself, and we'll get that the length equals 30 minus the width. Okay, so now we can use this, and it's really almost like substitution and elimination, or substitution rather. We can take this value for the length and substitute it into our area formula. Area then will be 30 minus W times W, so length times width. If we multiply that, and I'm just going to change the order, if we do that, we end up with area equals negative W squared plus 30W. Okay, so now it's a quadratic equation with just one variable of W, the width. If we look at that quadratic equation, we can see that the value of A is -1 and the value of B is 30. So we're going to use this great little formula for the vertex and say that the W coordinate of the vertex will be -b over 2a. And I'm going to just switch to the next page and we'll substitute the values in, okay? So our width is -b over 2a, and we'll substitute those values in. So we get -30 over -2, and W equals 15. So there's the width of the perimeter. The reason we got the vertex was that vertex gives us our maximum point. So the area equaling the length times width will be maximized at the vertex. So there's the x coordinate, or rather the W coordinate of the vertex. And we know from up above that the length equals 30 minus the width. So then the length will also be 15. And so the dimensions are 15 by 15 meters. And the new area then will be 15 times 15, which will be 225 square meters. Okay, so start with looking at the information that you have, write down formulas that you know, and try to get whatever it is that's being maximized or minimized. You need that formula to be rearranged so that you only have one variable in it, and then you can find the vertex, which will give you the minimum or the maximum, depending on what the question's asking. And that's it for that type of question.